Hello, welcome to another special Sudoku solve video. I saw this puzzle yesterday and I thought it looked very interesting. It's somewhat of a connected killers, and I thought it'd be interesting since I'm also working with killers in some way, and double shapes and that kind of stuff. So I wanted to look at it and see uh, what it would do, what it would implement for kind of logic. So normal Sudoku rules apply, okay. Escape killers. Digits do not repeat on a killer line or in a killer cage. So the pink lines are killer lines. The total of a killer line is the same as the total of the killer cage it is escaping from. Okay. So let's enable the ladder tool. Let's see if can I do like this, okay. Let's pick this cage, right? If we call this A, this B, and this sum C, right? And the total sum of this cage is going to be D. The sum of the pink line is the same as the one of the killer cage, right? So that's also D. So then we're saying for the killer cage, it is A plus C equals D. And for this line, it is A plus B equals D. Now, if we subtract A from D, right, we get a value. Well, no. Let's do it in a better way. If we rearrange this equation by subtracting A from D, we get C equals A minus D. If we do the same with B, we get B equals A minus D. So that means B and C are the same, right? So in any cage, whatever is not common, so this cell is the same as those three cells, which means that this is 6, oh, not like that. Let's go back to numbers and do 6, 7, 8, or 9. Is that the case anywhere else? This looks interesting. This is 5, this is 9 cells, and then this is also 9 cells. Yeah, it is. That is interesting. What I think is also interesting is these two cells, right? Yeah, because they sum to the same as this, and the minimum for these is 1, 2, 3, 4, 5. So that's 15, so this is a minimum of 15. Okay. Where are these two digits going within this box? Right, because they're not going here, because they're on the same line. They're not going here, so they go here. How do we color that? That's, yeah. And then they're up here somewhere, but I don't know where. Right, okay. Is that interesting? Well, okay, so these three cells, where do they go on this line? They don't go here, they don't go there, so they go in these cells. Okay. Where do these two cells go in this cage? They don't go there because that's green. They don't go there, so they go there. Right. That must be correct, right? I don't know, that seems weird to me that it places it there, but I don't know why. It just feels wrong. Within this box, where do they go? Right, because these are 15 in total, right? So we can have a digit there, one of the red digits, and that's fine, that is whatever. But this can only be a 6. So it could be a 6 and a 9. But could a red digit be there? if a red digit is there, what are we saying? If it's 9, the minimum for this is 19. That doesn't work. If it's 8, the minimum for this is 18. That doesn't work because this cannot sum to 18 or 19. So 7, 17. That is possible with an 8 and a 9. But then, okay, so I'm asking, can this be a red digit? And I don't think, maybe 6, but 7 doesn't work. 7 doesn't work, because then you have 17 and then this is an 8-9 pair, and that still then isn't a red digit. Could this be a 6? Then we have 16. Then we have 7 and 9. And that still isn't a red digit. And if this doesn't contain a 6, that cannot be a red digit. So either that's a 6 or that's a 6. Well, no, that couldn't be a 6 either. So those are both red digits. And we know that that's a maximum of 6 because then this is a 9. Because if we make this any bigger, we have a problem with this. So that's a 1-2 pair. And that's a 9 because this is a minimum of 15. That does seem correct. So now that's a 9. One of those is a 6. It's not this one because of the line. Okay. And this is what? 1, 2, 3, 4, 5? I don't like the pencil mark, but I'm going to keep it, I think. Okay. So we need a 7, possibly. And whatever this digit is, and an 8. Okay. That's something. Oh, right, this is another one of these. Because this is one cell connected to 3 cells, so this is a 7 or an 8. Oh, and this cannot be 7 because then this is 1, 2, 4 and it breaks that cell. So that's an 8 with... What can be 1, 2, 5 is not possible, so it's 1, 3, 4. So we know that that's a 5. And that's a 2, that's a 1, that's a 6. That's not a 6. That's not a 1. And this cell practically doesn't matter. Same for these 3, right? They mean nothing, I don't think. Weird. Okay. I don't know how to work with that. This is 1, 2, 3, 4, 5, 7, and 8. Well, this isn't a 5 because that's a 5. And that sees it in the cage. These 1 and 2. We know that this is a 6-9 pair. So where do 1 and 2 go within this cage? They go there. And I guess this is also a 5, 7, 8. So that's a 5, 7, 8 triple. So we have 1, 2, 3, 4. 2, 3, 4, where this is in 1, 2. So that's the 3, 4 pair. And 1, 2, 3, 4, 5, 6. And then we have 7 and 8. Yeah. Where does this digit go within this box? It goes there. So that's a 1 or a 2. I'm not sure how this gets resolved. Okay, I had to put my laptop on a charger, but that's okay. Right. One of the green digits is 5, and within this box it goes there. So we have either... Well, okay, so this 8 places 8 in here. And also, green does contain a 5, so 5 isn't there, so 5 is there. Now, if one of those is 8, if one of those is 8, then the minimum we can add to it is a 1, and that would have to be a 9, and that's not possible. So that isn't an 8, one of those is an 8, so that's not an 8. Sure. But how do we go any further? I don't know. Maybe another cage? This contains 3 and 4. Whatever. Oh, well, one thing. Where does 8 go on this line? It doesn't go there, it doesn't go there, it doesn't go there, so it goes in one of those two and it can only go there. So that's a 7. So we know that that's not a 7. We know that green is a 5-8 pair, so that's a 5, so neither of those is a 5. Now, that could be a 5-3 pair. 3-5 pair, and that'd be an 8. That would make that a 3, interestingly, because if you place a 3 there, it can only go there on the line. If you place it there, it can only go there. That's weird. Okay, but that is a 3-4-7 pair. Okay. 7 on the line goes somewhere there. If one of those is a 5, right? We can add 1 to it and make 6, but that's not possible. We can add 2 to it, make 7, that's not possible. We can add 3 to it, make 8, that's possible. We can add 4 to it, make 9, that's not possible. So only thing we can do is a 5-3 pair with an 8. That does mean that what I said is true, that one of those is a 3, because if that's a 3, it cannot go there on the line, so it must go there. And the same thing goes the other way, so that's a 3. That's a 4, those are in 3s. Those are in 3s. Right, and the other digit, the digit that goes here, goes there on the line. Which cannot be a 1. Sure, that does mean... Oh, well, no, wait, well, yeah, okay, that's interesting. If that's a 1, that's a 1, and that breaks this, right? If that's a 4, that's a 4, and that breaks this as well. So 1 and 4 within this box must go here with the 7, 1, 4, 7. And then in the killer line, what do we have? 1, 2, and 3? Yes. Makes sense. 3 in this box is in one of those. Because it's not there because of this. And what am I missing? Well, a 2. Okay. So that's a 2, a 3, a 3, and a 5. So one of those is a 2, one of those is a 2. So that's a 2-3 pair. So what is this? 1, 2, 3, 4, 5 I have, so it's 6, 7, 8, or 9, which that is in an 8. Why I thought that'd be interesting is because I don't think that can then be a 6, because then that's a minimum of 7, and there's something added to it, so it doesn't work. 7, it could be 6 with a 1, but that cannot be a 1, so that's not true. 8 could be a 6 with a 2. That seems possible. That seems possible. 9 could be a 6 with a 3. Or a 7 with a 2. So that's this. I think that's it. But that's a 2-3 pair, which I don't know if it does anything, but I thought it'd be interesting. 6, 2. No, I don't think that does anything. Well, okay, 1, 4, 7, that cannot be a 7. Right, either one of those is a 9 because of those 9s, but... So that's not a 9. So that's a 6. It can only be a 6. So that's a 7, that's a 2, that's our 9, and that's our 8. So that's a 3, that's a 2. Okay. So one of those is a 6. Why I thought it'd be interesting, because if that's a 6, we cannot add a 1 to it and make this a 7. We cannot add a 2, but we can add a 3 and make that a 9. That doesn't work. So if the 6 is in here, it goes with a 1. But sure, right? I'm not sure what that means. Within this row, 7 and 8 cannot go there, so that's a 7 or an 8. So that's a 7-8 pair. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay. So this 6 now is either a 6, 1, which still seems possible to me. I know which digits these are. It is 1, 6, 3. So how can you make, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, yes. So how can you make one of those digits? I can only see 7 with 1, 6. So that must be the case. So that's a 3. That's 3 in the corner as well. With that being a 7. That being an 8. That's a 7. And which digits am I missing here? 1, 2, 3, 4, 5, 6, 7, and 8. 8. 5, 8. That's an 8. So that's an 8. And that's our 5. So 5, 5. So one of those is a 5. Well, I know what these digits are. It is a 1, 2, 3, 4, 5, 9. If that is a 9, that's a 9. So that isn't the case. So that's a 5 and a 5 and a 9. That 5 places that 5 and that 8. I'm going to remove that coloring now because I don't like it anymore. And I think what I could have done way before was this 9 places that 9. And that's 6 as well. This 1, 2 doesn't makes that not a 1. Really? Okay. That's not a 2 or 3. Okay. I thought that'd be more, but it isn't. Yeah, and I'm missing some stuff here, but... So what? These aren't a 9. This is not a 9. That's not a 9. So one of those is a 9. 6, 6. Makes that a 6. Oh, well, I didn't want to do it like that. I wanted to do it like this. That's 6 blocks. Those two, that's 6 blocks. Those and that doesn't. I thought I had something, but I I looked wrong, I guess. What am I missing in this column? Still a 1 over 4. And this is 1, 4, and 7. 1, 4, 7. Right. Okay. Six, 6. That's 6 blocks from there, so one of those is 6. Right, and this is the point where you have to look at Sudoku, or I have to fidget with this line and figure something out, but I'm not sure. If I put, so in this row I still need an 8 and a 6. Right, okay, so in this row where does 8 go? It goes in one of those, because if it goes there, right, this 9 and this 9 are equal, then this 8 with 2 digits added has to be something with those two, and that's not possible. Because that's the most you can make is 8, and you need to add 2 more digits, so that's not the case. So this is also a 1 over 4. That's something. And now you need to add 2 more digits. So could that be a 1-4 pair? Then it's 5, right? 5, you can make 5 with 1, 1, 3. For example, no, that does seem to work. I wish I had to add, I hoped that I had to add like the, right, in this row, what am I missing? I'm missing 5 and 8. And I saw those. So that's a 5-8 pair. And then this is a 3, 4, or 7. That's sharper than I thought I'd be. Right, so what now? Sevens? No. I'm having trouble assessing sevens because 7 is in one of those. 9? One of those can be a 9. Something else there? What am I missing here? I'm missing some high digit. A 7 could either be there or there. And then it's 2 and 3. Yeah, okay, no, I don't like that. Where? There must be some line that I can figure out anything by. And I think it must be this one, because that's the only one I haven't really used. So these 3 digits add to those 2 digits. If that's a 4, then we know that's a 7. If that is a 1, then that is a 1. Then this doesn't contain another 1. So then the minimum for this is a 2 and a 3. Okay, so that must be a 7. Okay, that makes sense. If this is a 1-4 pair, then this sums to 5, then these have to sum to 5 as well. If that's a 4, that's impossible. If that's a 1, that's a 1, then neither of those can sum to 1, so the minimum for these is 2 and 3, making it also not be able to be 5, so that's a 7. That's not a 7. Still don't know what that is. But one of those is a 7. Okay, so much trouble for barely anything, I think. Right. Is it possible to make 8 even? 4, yeah, 1 and 3. Does seem to fully work. Wow. I thought it was going very well, but I stopped doing well. Is it something else? 5, I have all 5s. Oh, wow. 4, 5, 5, and 8. That was very obvious. I'm sorry. Okay. I don't like that, but that's what it is. So simple. 4 then, that makes that a 1. That could still be a 1. Makes that a 1, that a 6. Makes one of those a 6, but this 6 blocks it from there, so that's a 6. That's a 9, that's a 9. Two makes that a 2. Makes that a 2. So the minimum for these is already 3, 4. Actually, that's now not a 4. So this is a 3 or 7. If that's a 7, then that must be a 3. Because then that has to be a 4. Yeah, okay, so that isn't a 7, that's a 3. 4, 3. Another 3 in the corner. Because why not? Oh, those are missing. What am I missing here? These sum to 4. That couldn't be a 7. Right, either this is 8 with that as a 4, or this is 11 with that as a 7, and that cannot be a 7. So that's a 4, that's a 1, that's our 4, that's a 4. Right, what now? Those are in 2s, so we know that that's a 2, that's a 1, that's a 3. 1, 2, 4, 7, 9, 6, 7, 1, 1, 4, 7, 1, 2, 3, 3. What am I missing? Oh, 1 and 4. Very interesting. Very interesting how that worked. I don't think it was a 3-star puzzle though. It was listed as a 3-star puzzle, but I don't think it was. It was very nice. The way the gauges interact. I did the formula thing in the beginning as a proof, but I think it's a very straightforward example. I like that. I like very well how that was implemented. The minimum maximum constraints is also something I like, and that's what I'm trying to incorporate in my puzzle a bit more. So that was cool to see. Great puzzle overall. Thank you for setting. Have a nice day.